area of a triangle when we don't have the base and the height the way we've traditionally learned to use it. So in a triangle like this one, we learn that the area is always the half of the base times the height. In a lot of ways it's because a rectangle or square is base times height, and when you cut it in half you get a triangle. So when the triangle is like this, we can actually make it a parallelogram, which again is base times height. So when you have a triangle, it's always half of the base times height. And the one thing we always need to remember is the base and height must be perpendicular, meaning we need to make a right angle here, a 90-degree angle, so the base and height must be 90 degrees to each other. So we don't always have that in real life, and we've devised a way to find it using sine. However, we need to understand how the A and B's work. You traditionally will have a capital A, capital B, capital C. And then what we've been focusing on in my class is that the opposite angle, it goes with the opposite side. They work together. Just like in a right triangle, opposite of that is the hypotenuse, the right angle, because opposite of the biggest side is the biggest angle. So across from angle A, we're going to put side A, a little a. Across from angle B, we're going to put a little b. And then across from angle C, we're going to put a little c. It doesn't look very little, but... So we're going to distinguish between a capital B, A, B, and C, and a lowercase a, b, and c. Maybe for the capital C, I'll put a little extra curve on the top of it. So here we have A, B, and C, and so when we're going to decide on finding the sine of using an angle and using two of the sides, what we're going to end up doing is we're going to pick an angle. So we're going to use, let's say in this case, A, and we're always going to use the included sides. So the two sides touching that angle would be considered B and C. So we can label them anywhere, so really we can choose the bottom one and call that A, and then call the other ones B and C. And we'll just have to get used to this pattern. But we're going to use the angle and two of the sides. So the other two sides that are not the side across from angle A. So the two sides touching and forming angle A we're going to use, as well as the angle A. We're going to use the sine of it. So the formula itself is not very difficult at all. It's going to be 1/2, just like the area formula. But instead of the base and the height, we're going to use the two sides that were touching that angle. So we're going to use whatever B is times whatever C is. And then we're going to finish it off by multiplying it all by the sine of that angle we're using, sine of A. So again, we're going to take the angle and use the sine of that angle. And then we're going to multiply the two sides touching it, B and C. And we're going to multiply all of it by half in the end. So let's try a couple of questions and see how we would find the area. So if I quickly draw a triangle, and I have 38 degrees, and I have 220 and 110. So even if I have other numbers here, okay, we want to focus on the fact that we're only going to use one of the angle and the two sides touching that angle, or what we call the included sides. So let's call this one, I don't know, 52. No, that wouldn't work out right. So 82, so that would be 90, 120, so this would be 60. So I'm going to find this area, and all I need is one angle and the two sides touching it, but I filled everything in. So I'm going to use 38 and the two sides touching it. So what we had said was we're going to use the sine of the angle, sine of 38, and we're going to use the two sides, the 220 as well as the 110. So I'm going to put 1/2, the two sides, 220 times 110, that would be like the B and the C, and then I need to put the sine of 38 degrees. So when I break that down, I'm going to use the calculator to find my sine and cosine value. And I'll do that first. So I'll take 38 of sine. I don't need to get the missing angle, so I just push the sine button, not the inverse. and I get 0.6156. So I'm going to take 1/2 0.6516 times 220 times 110. And let's finish. So I already have the sine of 38. By leaving this and not reducing it to the first 4, it's actually going to be more accurate. So I'll leave this up. Multiply times 220 times 110, and I can then divide it by 2 at the end, or multiply it by 0.5. Multiplying by half is the same as dividing by 2. 749.5. Wait, what was that? 7449. So it's not a very difficult thing to do. Let's try one more. I'm starting to get workers outside, so it's making noise, but hopefully it doesn't get much louder. So let's try another one. 67 degrees, and 24, and 18. So now I'm only writing the ones that we're looking at. I'm going to take 1/2 18 times 24, the two sides that are touching the angle, and then sine of that angle. And I always like to do the angle sine first, 67 of sine, times 18 times 24 times 0.5. Remember, half is the same as 0.5. 198.8. So if we're using a calculator to multiply, we want to multiply by 0.5, that's what half is. Or at the very end, instead of multiplying by half, we could divide by 2. Dividing by 2 is dividing by half, or multiplying by half. So hopefully that makes sense. It's not very difficult at all. When you have multiple numbers, just ignore them. And we're just going to use, so let's say I have 38 here and 20 here. So which angle do I have to use? Well, I have to use the 72 because those are the two sides forming the angle 72. So I'm going to say 1/2 20 times 38 times the sine of the angle that's being used or being formed by those two sides, sine of 72. So again, I'll clear it out, push 72. Those of you using an Android, you would put sine and then push the number 72, times 20 times 38 times 0.5, 361.4. So the only other thing you might see is a sentence, or what they might call a word problem, but it's not really in the traditional sense. So let's try that. The two included sides are 12 and 18, and the angle formed is 37 degrees. Find the area of the triangle. So we really don't need to draw the picture, right? We can pick apart the information we're given, the included sides, so it's half 12 times 18, and then the sine of the angle. Okay, but if we wanted to, we could draw a sketch, have 12 and 18, and the included angle being formed is 37. So that should do it for us. Solving the area of a triangle using sine.